Good morning, children. Let us start exercise 6.2. That is, find the square of the numbers 32. That is first question, first part, and fourth part. That is 93. What is this 32? Find the square of the 32. That is means 32 square. You have to find out. Clear, children? That is 32 square. This can be written as 30 means 30 plus 2 is square. Now what is the motive behind writing it like this? Clear, 32 can be broken up clear in two parts in such a way that the first part is the multiple of 10 and another part is one digit. Okay, children? Now this is 30. This is equal to what? 30 plus 2 multiply by 30 plus 2. Okay, children? Now what is this? This is now using distributive property. That is, this implies that what? 30 into 30 plus 2 plus 2 into 30 plus 2. What is this property known as? This property is known as distributivity. DIS. Distributivity. This is called distributivity. Now children, this is equal to 30 into 30. 30 into 30 plus, that is 30 into 2, clear, plus 2 into 30 and plus 2 into 2. What is this property known as? Distributivity of multiplication over addition. Distributivity of multiplication over addition. Okay, children? Here what is this? Here multiplication is distributed over addition. Okay, now simplify the things. 3 3 is 9 and that is 9. 2 zeros plus 3 2 is 6. This is 60. Okay, plus that is again 60 plus this is 4 equal to what? This is 960. What is this? 900. This is 32 is 60 and this is 60 and this is, now this is 900 plus 120 and 4, that is 124 equal to what is? 1024. Means what? What did you get, children? It means that this is, what is this? 13 to 30, this is 3 3 3 is 9, 3 to 60 60 plus 4. Okay, that is 900 plus 124 plus that is 1024. It means that square of 32 equal to 1024. So this is the method we have to use rather than using the direct multiplication, that is 32 into 32. This is how we find the square of 32. Let us see one more part, that is question number 5. This is fourth part, that is 93 is there, children. Clear? That is square of 93 you have to find out. That is 93 square equal to, you break it up, 9 plus 90 plus 3 square equal to, what is this? 90 plus 3 into 90 plus 3. Okay, now let us start distributivity. That is 90 into 90 plus 3 plus 3 into 90 plus 3. What is this property known as? Distributivity. This is called distributivity. And now this is 90 into 90, clear, plus what is this? 90 into 30, 90 into 3, that is plus 3 into 90, clear, plus 3 into 3. What is this property? Distributivity of multiplication over addition. Okay, children? Right? Now let us simplify this thing. Equal to 9 9 81 and 2 zeros, clear, plus what is this? 3 9 27 and 1 0 plus 3 9 27 and 1 0 plus 3 3 9. Now add, that is, see, add ones place, that is 9 9, that is 9, then tens place 7 plus 7 14, 14, 4 is there, 1 is carry over, then hundreds place 1 plus 2 3, 3 plus 2 5, 5 and 1 6 and 8. Clear children? Now what is 4 540, that is 600 640, and this is 649, and this is 8600. So what is this means? I want to say that square of 93 equal to 8649 children. Okay, you can check the calculation here. See, 90 into 9 into 99, 9 81, 2 zeros, 3 9 27, 1 0 is there, 3 9 27, 1 0 is there, 3 3 9. Now 8100, this is now ones place 9 is there, tens place 7 plus 7 14, 4 is there, 1 is carry over, then 2 and 1 3, 2 5, 5 and 1 6 and 8. Okay children, now this is next question is related to Pythagorean triplet. Pythagorean triplet is what? Let us once again define the Pythagorean triplet, that is, then move to question number 2. What is Pythagorean triplet? Clear? Let us define it. For any natural number m, for any natural number m greater than 1, we have, what do we have? We have 2m square, 2m whole square plus m square minus 1 plus m square minus 1 square equal to m square plus 1 whole square. Clear? If this condition is satisfied, clear, then so what? So 2m m square minus 1 m square plus 1 form a Pythagorean triplet. Form a Pythagorean triplet. Okay children, this is the definition of Pythagorean triplet. For any natural number m greater than 1, we have 2m whole square plus m square minus 1 whole square equal to m square plus 1 whole square. So 2m m square minus 1 and m square plus 1 form a Pythagorean triplet. That is just like your Pythagoras property. This is what? This is hypotenuse. Clear? And these are the sum of other two sides, sum of the squares of other two sides, that is. Okay children, let us move to question number 2, that is, what is this? Write a Pythagorean triplet whose one member is, write a Pythagorean triplet whose one member is, let us take 1 is 6, whose one member is 6. One more question we will take, whose one member is 18, whose one member is 18. Let us take, that is fourth part of this question only, that is 18. So start first, let us solve. Okay, let see what are the Pythagorean triplets. 2m m square minus 1 and m square plus, let 2m equal to, let see actually start here, we write down, we can get Pythagorean triplets by using general form. Get Pythagorean Pythagorean triplet by using general form. What is general form? What is general form children? That is 2m m square minus 1 and that is m square plus 1. These three are known as Pythagorean triplet. So let children, let 2m equal to 2m equal to one of the members of the Pythagorean triplet, it is given, that is 6. So let 2m equal to 6. This implies that m equal to 6 upon 2 equal to 3. This implies that m equal to 3. Clear children? Now m square minus 1 equal to 3 square minus 1, 3 3 is 9 minus 1 equal to 8. Clear? This implies that what did you find? M square minus 1 equal to 8. That is the other member of Pythagorean triplet is 8. Clear? Again, m square plus 1 equal to, that is 3 square plus 1, which equal to 3 3 is 9 plus 1 equal to 10. This implies that children, this implies that what? This is m square plus 1 equal to 10. So what are the three members? See, this implies that the Pythagorean triplets, the Pythagorean triplet are what? Are what? 2 are, that is 2m, that is 2 into m equal to 3, then 8 and 10. Yeah, that is what? 2 3 is 6, 8 and 10. Okay children? So 6, 8 and 10 are Pythagorean triplet. Similarly for this fourth part also of the same question, you can find out the Pythagorean triplet. Clear children? Now let us move to the fourth part. What is it about? Fourth part, here it is given, one of the members is given to be 18. One of the members of the Pythagorean triplet is given to be 18. So you have to find the other two members. Let us proceed. That is second part. One of the members is 18, it is given. Clear? That is, now let start. Let 2m equal to 18. This implies that m equal to 18 upon 2, that is equal to 9. This implies that m equal to 9. Clear children? Now what is the next member of the Pythagorean triplet? That is m square minus 1 equal to, what is m? That is 9 square minus 1, which is equal to 9 square equal to 81 minus 1 equal to 80. Okay, that is m square minus 1 equal to 80. So other member of Pythagorean triplet is 80. Clear? And one member is 18, that is 9 9 is 81 minus 1, that is 81 minus 1 equal to 80. Now again, again that is m square plus 1. What is m square plus 1? M square plus 1, that is 9 square. 9 square plus 1, that is 9 9 is 81 plus 1, that is equal to 82. Okay children? So this implies that m square plus 1 equal to 82. So what are the Pythagorean triplet? So the Pythagorean triplet are what? That is 2 into 9, that is 18. Okay, then 9 square, 9 is 81 and 81 minus 1, that is 80, that is 80 and what? And 82. That is what? That is 18, 80 and 82. Okay children? So this your exercise 6.2 came to an end. Now what is square root children? Now coming to square root. See, what is square root? Clear? How to introduce the this concept of square root? Let us start. Square root. Square root. What is square root? 1 square equal to 1. 1 square equal to 1. This implies that square root of 1 equal to 1. Clear? 2 square equal to 4. This implies that square root. This is the symbol of square root. What is this? This is the symbol of square root. Square root. Okay, children. 2 square equal to 4. This implies that square root of 4 equal to 2. See the analogy, see the similarity of writing. That is 3 square equal to 3 3 is 9. Then we say that square root of 9 equal to this 3. Okay. Similarly, square root of 4, square of 4 equal to 4 4 is 16. This implies that then we say that square root of 16 equal to 4. Similarly, 5 square equal to 5 5 is 25. This implies that square root of 25 equal to 5. So now you must have understood, children, what is square root and how can we define. What is the official definition of square root? Let us define it. The square root of a number definition. The square root of a number A. Let us A be a particular number. A number, the square root of a number A is that number which when multiplied by itself to give A as by itself to give, which when multiplied by itself gives, here comma, gives A as the product, Children, did you understand? The square root of a number A, let A be a particular number, is that number which when multiplied by itself, clear, gives A as the product. For example, we can take in general we can write, algebraically we can write it, if b square equal to A, clear, then we say that we say that under root A equal to B. Clear that numerically we have already shown over there. B square equal to A here, 2 square equal to 4 here, B square equal to A. Then we say that under root A, that is square root of A equal to B. Okay, children. Here see one more thing I would like to emphasize, that when we take square root of any number, we will take both positive and negative signs. Square root is positive and negative both. Okay, children, because see 3 square equal to plus 3 square equal to 9 and minus 3 square is again 9. So the square root of a number is in positive and negative both. Okay, children. Here one note is there. What is the note? Let us emphasize it. That is square root of, children, square root of a number, note, write down. When we take square root of any number, when we take square root of any number, clear, we take both positive and negative sign. We take both positive and negative sign. Why it is like this? Because see, square root of 9 equal to, that is plus minus 3. Why? As see, plus 3 square equal to 9 and minus 3 square is again 9. Clear? And that is according to the definition of square root. Clear? Square root of a number A is that number which when multiplied by itself gives a as the product. Okay children, so this is now square root. Now finding square root, let us move ahead. Now but here clear in your syllabus, clear we will take only this positive square root only. Clear. Now let us move to exercise 6.3. Exercise 6.3 children. Exercise 6.3. What is it about? Let us move to exercise 6.3. What is this? What could be the possible ones digit? First question. What could be the possible ones digit? Possible ones digit means ones digit means digit at one's place. Ones digit. Ones digit of the square root of the square root of each. Okay children, that is first, that is 9801. 9801. Clear. You have to find out without finding actual square root. Clear. What would be the this ones digit of the square root of 9801. Okay children, let us start. How to this? You know that children, see the square of a number ending either with 1 or with 9 will have one in this see in the one's place of its square. Means I want to say that clear, if a number is ending with either 1 or 9, clear, then its square will what? Then its square will be ending with 1. Did you all understand? If a number is ending with 1 or 9, ending with means digit at one's place is 1 or 9, then its square will end with 1. That is sure. So here the just opposite we have to think. 9801 is the number. What could be the possible ones digit clear in the square root of 9801? It is obviously 1 or 9. Because see, if we square 1, then again 1 will be obtained. If we square 9, then again 1 will be obtained in one's place. Okay children, so let us write down here 1 is the 1 here in 9000 here in 9801. One's place is 1. One's place is 1. Okay children, now we know that. What do we know? What do we know children? That squares of 1 and 9, that the squares of 1 and 9 gives out clear 1 as one's place. Here in 9801, one's place is 1. Okay children, and we know that 1 and 9 gives out 1 in one's digit. We know that the squares of 1 and 9 gives out 1 at one's digit. Okay children, so this implies that possible one's digit clear of the square root of 9801 clear, that is that possible ones digit of the square root of 9801 clear are what? 1 or 9. Okay children, that is 1 or 9. Okay children, let us revise the things here. In 9801, one's place is 1. Okay, means digit at one's place is 1. Now we know that the squares of 1 and 9 gives out 1. Clear? At one's place, I want to say that square of 1 is again 1. Square of 9 gives 1 in its one's place, that is 81. In 81 one's place is 1. So one's digit, this implies that possible one digit of the square root of 9801 are 1 or 9. Okay children, similarly other question can also you can take, that is here see third part is same, and this fourth part is that will be 5. Let us see second part also. See, that is number is 99,856. Here start solution. How will you give the reason? Here in 99,856, digit at one's place is 6. Okay children, now we know that. What do we know? Now we know that. Clear? When will we get 6? Clear? See, if we take the square of 4 or square of 6, 4 4 just 16 and 6 is just 36. Square of 4 and square of 6 gives out 6 at one's place. Okay children, now we know that. What do we know? That the squares of 4 squares of 4 and 6 gives out 6 at one's place. Okay children, this implies that possible one's digit of the square root of what number is there? 99,856. Clear? Are so possible one's digit of the digit of the square root of 99,856 are what? 4 and 6. That is 4 and 6. Okay children, and this is the answer. This is how you have to give the reason and logic clear behind your question. Now children, let us move to, it is going to be now next question, that is without doing any calculation, find the numbers which are surely not a perfect. You are surely not a perfect square. Children, you know that numbers ending with 2, 3 or 7, 2 or 3 or 7 or 8, clear, they can never be perfect square. Clear children? And other may or may not be. Clear? Let us see. Without doing any calculation, write down. Without doing any calculation, find the numbers which are surely which are surely not perfect square. Here let us see children, first part is 153. Here see, how will you give the reason solution? We know that numbers ending with 2, 3, 7, 8 can never be, can never be a perfect square. Perfect square number. Okay children, here 153 is ending with means ones digit ending with what? 3. Clear? So 153 is not a perfect square, not a perfect square. Children, so this is how you have to give the reason in each case. Clearly, here see 153 is not a perfect square. 257 is also ending with 7, so it is also not a perfect square. 408, clear, it is also ending with 8, so it is also not a perfect square. Whereas 441, clear, 441 is not ending with 2 or 3 or 7 or 8, so it may be a perfect square. Okay children, that is fourth part also. Let us see 441. Clear? How will you give the reason? Solution. Same thing, we know that number ending with 2, 3, 7, 8 can never be a perfect square. But here 441, clear, is not ending with 2, 3, 7 or 8. This implies that, clear, 441 may be or may not be, may be a perfect square. Children, what is the reason? See, what is the proper logic? See, it is number ending with 2, 3, 7 or 8. Clear? They can never be, there means they can never be perfect square. That is definite. Clear? But the number which are not ending with 2, 3, 7 or 8, clear, they may or they may not be perfect square. There is no guarantee that they will be perfect square. They may be perfect square, means 50% possibility is there. Okay children, now the video is going to be larger. Now children, this is enough for today's class, and see in the next class we will see the next part of the exercise. Okay children, thank you and have a nice day.